Okay, now it's part 3. Start from question 1. The number. Okay. 300 million can be written as scientific notation, which is this guy, of course, with 1 here and 8 zeros. The fundamental SI units for mass, length, and time, respectively, are: for mass is kilogram, and for length is meter, for time is seconds. A millimeter is a millimeter. Okay, this guy is How many nanometers are in a kilometer? A nanometer is 10 to the power of -9 meter. This is nanometer. And 1 kilometer is 10 to the power 3 meters. So 1 kilometer. How many nanometers are in a kilometer? So you can do this. How many nanometers are in 1 kilometer? 1 kilometer over 1 nanometer. So calculate the ratio, which is 10 to the power of 12. The data plotted are a graph of distance on the y-axis with time. On the axis, use a linear graph. The slope of the graph is the definition of slope. This is easy, something very easy. The definition of a slope is part 2, part 3. Question 5. The definition of a slope. Once you have x-axis and y-axis, the definition of the slope is how steep a line is. Generally, for any segment, you calculate the change in x and you calculate the change in y. Then the slope is delta y over delta x. To be more strict, you need to limit delta x equal to 0. So slope is defined as delta in y component over delta in x component. Consider the velocity with time graph showing. Velocity with time. The area under the graph. So this part is a trapezoid. Upper base plus the lower base times the height, which is this length 4 over 2. Which gives you 24. Data from experiment shows that kinetic energy is proportional to the square of velocity. The plot of graph of kinetic energy vs velocity would be. So change a variable. This is easy, so if I have to explain, I will say, since you know that energy is proportional, kinetic energy is proportional to V squared. So EK is proportional to V squared. So when the exponent, when the x-axis is V, then we have a parabola. The cosine of an angle in a right triangle is equal to. So the definition of cosine, which is not a problem for most, but for several students, this is still a problem. Okay, in a triangle, the cosine is defined as the adjacent over the hypotenuse. Cosine theta equals A over C. Okay, what about sine? Sine is the opposite, edge over the hypotenuse. So ratio of the adjacent over. Which of the following quantities is not a vector quantity? Which is not a vector quantity? Displacement is, of course, resultant, which is, of course, the sum of several vectors is a vector. Equilibrant. Okay, equilibrant mean that you have A. Equilibrant, you have A, and maybe you have negative A, and the sum is 0. Okay, this 0 is special. This 0 is a vector 0. A vector 0, does it have a direction? No, it has no direction. You can't say it's pointing anywhere, but it is a vector. What about this one? Okay, of course, this is displacement, a specific displacement, and mass is a scalar quantity. The resultant of two displacement vectors, east and 3 meter east and 4 meter north is. Okay, this time you have to calculate the sum of two vectors again, which is easy at this stage, I believe. Okay, which is 3 meters east and 4 meters north. Okay, I put the starting point at the ending point of the first vector, and this way I just form a triangle here. Then from the Pythagorean theory, this is 5, so 5 northeast. The next question, the x component of the vector is most nearly. X component again, x component. How to deal with x component? Of course, you should be familiar with cosine and sine this time, because it's always the same thing. Once you know what sine and cosine is, you know what the x and y component is. This time, okay, 10 meter, C is 10 meter. Okay, the angle is 30 degree. You want the x component. X component is A. A is 10 cosine 30, which is approximately times maybe 1.7, which is approximately 8.5, I guess. Okay, you choose the one which is most nearly. Two displacement vectors, each having a y component, are added together to form a resultant that forms an angle of 60 degrees from the positive x-axis. What is the magnitude of the resultant? Okay, this time again, the sum of vectors. Since we know that each vector has a y component of 10, which means finally we will have the y component of 20, and the x-axis remains unknown. The x component remains unknown, but it doesn't matter. You can always work out what it is. Firstly, we have the Cartesian axis, and secondly, we know that the resultant is a vector pointing this way with an angle theta equals 60, and this time we know the horizontal should be 20, and we don't know x component, but it doesn't matter. You can always calculate c. That is what you want. C should be 20 over sine 60. Why? Because c times sine 60 gives you 20. So how do I have 20 here? This is said in the problem that each component has a y, each vector has a y component of 10. So I know that the sum should be 20 in the resultant vector. The y component should be 20. Okay, if you are not sure with that, you can do that this way. Okay, for the first vector, you resolve it into x and y components, and for the second vector, you resolve again. So this is 10, okay, and this is 10 again. Then the final resultant vector should be ay plus by 20. Okay, this is why I say that the y component of the resultant vector is 20. So this is easy. Before you start to review SAT2 physics, you should be familiar with all of these simple vector algebra. Okay, and that's all for part 3. If you are not familiar yet, don't go on. Just make sure you understand everything. And that's all for vector.